Right now, millions of acres of farmland rely on a brute force approach to weed control. Heavy diesel tractors dragging massive booms, misting fields with millions of gallons of herbicides. But biology is pushing back. Weeds have evolved to survive these chemicals, creating resistant superweeds that force farmers to apply harsher, more expensive, and more toxic mixtures every single season. There is a very real human cost to this cycle. Aigen founders Kenny Lee and Rich Worden started the company because both had experienced health impacts from pesticide exposure while growing up around farms. Reverting to manual weeding isn't a viable alternative at scale. The agricultural sector is facing chronic labor shortages, leaving farmers without the workforce needed to maintain commercial fields by hand. This leaves mid to large row crop operations in a difficult position. They need a way to physically remove weeds that doesn't rely on chemical sprays, or on diesel fuel, or human crews. The conventional model of farming has hit a biological and economic ceiling. To keep these operations viable, the method of weed control has to change. The Aigen Element Gen2 rover is designed to operate within those constraints. It's a compact, fully autonomous machine built to eliminate weeds with zero chemicals and zero diesel. To stay in the field without a charging station or a gas tank, the Element is built around a custom 205-watt solar panel that serves as its roof. A tractor idles at thousands of watts, and a vacuum draws 1,200. The Aigen Element draws under 200 watts while actively weeding. With regenerative motors and high-capacity batteries, it maintains a 14-hour continuous operational window. Powering the rover is only half the battle. It also needs to make real-time decisions. This is handled by an onboard edge AI running on a highly efficient neural processing unit. Using stereo depth cameras and a visual model with 1.5 million parameters, the robot distinguishes a crop from a weed in milliseconds. It performs this processing using 1.5 watts, less power than many smartphones use. Pairing this hyper-efficient local compute with solar power allows these rovers to navigate and identify plants in the middle of a field, completely independent of the grid. Other autonomous weeders try to solve this problem by burning weeds with high-energy lasers, but those systems require massive power draws and heavy infrastructure to support them. Aigen uses physical contact instead. The robot is equipped with a mechanical system designed to interact directly with the soil. Underneath the solar panel, robotic arms operate with sub-millimeter precision. They deploy small metallic strikers to physically hoe weeds right at the root, pulling them from the soil while leaving the nearby crop completely untouched. The rover can switch between a sweep mode to clear out broad, early-season weed flushes and a targeted strike mode for individual weeds later in the growing cycle. In April 2026, Aigen began a commercial deployment with Bulls Farming Company, a major operation in California. Full crews of Element Gen2 robots are now actively clearing weeds in these large-scale Pima cotton fields, moving the technology from the lab into commercial production. For the farmer, the $50,000 unit cost represents a capital investment. The goal is to replace the recurring, unpredictable expenses of chemical applications and manual labor with a fixed asset. There is also a data advantage. Because the fleet lives in the field all season, it acts as a constant sensor network, sending crop health and soil moisture data back to a mobile app. By aligning these economics with the biology of the field, Aigen is establishing a viable alternative to the chemical cycle. If the results from this 2026 season scale, these solar-powered crews could change the way row crops are managed across the country.